Hello. In today's lesson, we're going to be talking about this particular unit, and this particular unit has to do with graphs and probability. So graphs and probability. So at the beginning, we're going to talk about different kinds of graphs, and we're going to talk about the advantages and disadvantages of different kinds of graphs, and we're going to show a little bit how to use each of them and when to use each of them. And we're going to give some examples as well. And then after that, we're going to move into misrepresentation of data, misrepresentation of data. So we're still talking about graphs, and we're going to be seeing different items and different details on graphs as well. And then we're going to be moving on to more probability stuff and independent events. So let's get started. So we're going to start here with graphs. And so here we're going to be talking about three different kinds of graphs. So this one is a circle graph. And as the name implies, you've got a circle. So usually whenever you're making a graph, you have to provide a title. So vending machines, and there should be a title here as well. Vending machine. So this one is a circle graph. You've got a circle, and this one is a bar graph. So you've got different bars. And this one is called a pictograph. Pictograph. And from the word here, you can see picture. So that means basically you are representing your data or information, because data means information. So you're representing your data or information using pictures. So also you have to give us what each of the, in this case, rectangle indicates. So a rectangle here indicates 2 students. So let's start here. So we're representing the same data on all 3 graphs, and the data we're representing is we're looking at a particular school, and the number of times that students used the vending machine last week in that particular school. So from this representation, we're saying that 35% of the students did not use the vending machine. 41% of the students used the vending machine 1 to 3 times last week. 13% of the students used the vending machine 4 to 9 times last week. And 11% of the students used the vending machine 10 or more times last week. So we're representing the same thing here. And so we're saying here that about 19 students did not use the vending machine last week, and we've got about 24 students that used the vending machine 1 to 3 times last week, and we've got about 7 students that used the vending machine 4 to 9 times last week, and we've got about 5 students that used the vending machine 10 or more times last week. So this is how you show bar graph. And this is the pictograph. And so here, we're saying that each rectangle represents 2 students. So we have to count. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. So we're saying 19 students, because this is half, meaning 1 student. So 19 students did not use the vending machine. And then this one is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. It's supposed to be 24 students. Actually, pardon me, 23 students. Yeah, this should be 23 here. Right there, yeah. So 23 students use the vending machine 1 to 3 times last week, and 2, 4, 6, this is half, so 7. So 7 students used the vending machine 4 to 9 times last week, and 246 students used the vending machine 10 or more times last week. So basically, I am trying to represent the same information by 3 different kinds of graphs. Now, it's interesting that we are able to represent the same data or information by 3 different kinds of graphs, but it's important for me to explain that certain kinds of graphs are better to represent some certain data than others. So I'm going to talk about the advantages and disadvantages of using each of these 3 different kinds of graphs. Now, whenever it's a good idea to use a circle graph. Sometimes we call this a pie chart as well. So circle graph or pie chart. It's a good idea to use the circle graph when you like a good opportunity of showing part to whole. So for example, right here I can see very well that 35% did not use the vending machine because I'm able to compare this part to the whole. So that's a really good thing about the circle graph. Now the circle graph is not the best when you need to know the number of students in this case that is actually using the vending machine last week. So whenever you need to know number in a particular question or data, the circle graph is not the best. But the circle graph is very nice whenever you need to know the percent, for example, say out of 100 of a particular situation. So, for example, here we have no idea the number of students that did not use the vending machine. All we know is that 35% did not use the vending machine. Now, the opposite is working here because here, unfortunately, the disadvantage is we're not able to fully compare part to whole. That's one. And also we're not able to find the percent just from looking at the graphs, because also when you figure out the percent, it helps you compare part to whole, and it gives you the fraction of the whole that you're dealing with. So in this case, for example, all I know is about 23 students use the vending machine 1 to 3 times. It does not readily compare, or it does not readily allow me to compare this number to the total number of students that we're talking about here. Whereas this one does that. The same thing applies here. So this does not readily help me compare the total number of students, for example, that did not use the vending machine to the overall total number of students that we have done, that we're comparing in this graph. So that will be the disadvantage. The advantage, of course, is for every single category, I'm able to determine the number of students that are in that particular category. So here I'm able to say, well, we've got about 6 students for 10 or more times using the vending machine and so on. And the same thing applies here, 2, 4, 6. I'm able to see that we've got 6 students that used the vending machine last week 10 or more times. Another thing I want to mention here is that in some cases, and this doesn't necessarily happen all the time. For example, in this case, it's easier for me to say, okay, one rectangle has 2 students, so 2, 4, 6, than for me to really look at this one. So if I don't look closely, I may not know that for sure this is 6. I may think it's 5. So I want to say right there that looking from that standpoint, there might be a little advantage in those scenarios or situations for us to go with a pictograph, because the picture is very clear and I'm able to see. But like I mentioned, these may not necessarily be the case, because in this case, I'm not really using graph paper. So probably if I use graph paper here, that may not be as big of an issue. But then without the use of graph paper, if I'm just using plain paper, then it's clear for me to see that 6 students use the vending machine 10 or more times here than here. Then the last thing I want to mention when comparing all these graphs is that for the pictograph, it's a nice one to use, although I feel it can be a little bit tedious or hard. And then whenever, especially you're dealing with really big numbers, then it's going to be even more tedious or hard to use the pictograph. So for example, over here we're dealing with 6 students. What if we have to draw out 100 students? What if we have to draw out 200 students? So I feel that situation might be more challenging in some situations. All right. All right. So now we're going to move on. We want to see some questions now. So this is an example here. So in this example, we are showing a particular grade 8 math class and their grades. So we're showing them with a bar graph, and we're showing them with a circle graph. So question A says at least 3 things that you know or you can see from the bar graph, and question B says list 3 things you know from the circle graph. C says that which of the 2 graphs best shows the number of students who got B and why. Well, let's see. Now, there are so many things we can show from the bar graph, but let's just choose some. So for example, I can see that 7 students got a final grade of A. I can show that 10 students got a final grade of B. I can show that 9 students got a final grade of C. I can show that 3 students got D, for example. I can show that the grade with the highest number of students is B. I can show that the grade with the lowest number of students is D. So those are some that I can show here. Yeah. So let me just write a couple down now. So highest number of students I can say the highest number of students got the grade of B. I can show that 7 students got A. I can show that 7 students got the grade of A. I can show that I can show that 3 students got D. So 3 students got the grade of D. So list 3 things you know from the circle graph. I can show that 24% of the students got A. I can show that so from here I can show that majority of the students here got C. Oh, I apologize, that's incorrect. I can show that actually this is so the highest number of students got B because 35 is the biggest number. So 35 is slightly bigger than 31. So highest number of students got B, and that is 35%. The least number of students got D at 10%. Also, this space is the smallest out of all four. Now, see, which of the graphs best shows the number of students who got B? So which of the graphs best shows the number of students that got B? Well, the graph that best shows this is the bar graph. Why? Because I can literally come here and I can see that 10 students got B. Over here, I can't. And unfortunately, that's a disadvantage for the circle graph. All I can tell you here is 35% of the total number of students got B. I can tell you that 10 students got B. So I'm going to say the bar graph So the bar graph, and I can see that there are 10 students from the bar graph. I can't see that there are 10 students from the circle graph. Alright, this is another example here. So we have a pictograph here, and this is the favorite ice cream flavors. And this is chocolate, vanilla, and bubblegum. Now, so we're talking about misrepresenting data. So we have to be very careful because sometimes these can happen. So the student that was doing this has misrepresented data here, because from looking at this, if a person does not take the time to look closely, they're going to think that the item with the highest number when it comes to favorite ice cream flavor is bubblegum. Why? Because this ones are so big, so a person can think it's this. But really, that is wrong, because the highest number here is actually chocolate. Because chocolate has 1, 2, 3, 4. Whereas bubblegum has only 3. 1, 2, 3. So we have to be very careful. So because the student here has made this mistake. So at the end of the day, the sizes really should be equal, because every single one is representing the same thing. So each one is representing 1, and so we've got 4 here, and we've got only 3 here. So chocolate is actually more than bubblegum. So yeah, so please let's be very careful here. All right. We have another example here. So we have this one here. So this portion is milk. This portion is water. Actually, excuse me. Yeah. This portion is water. This portion is pulp, and this portion is juice. Now, if we don't look clearly, if we don't look carefully, we might think that milk is the biggest portion here, but no. Now, we might think milk is the biggest portion because if we notice, milk is being taken out. So the student that is working on this is highlighting milk, or is making us think that milk is more important than every other one. And it's making us think that perhaps milk has the biggest proportion, or portion in this case, but that's not the case. The one with the biggest portion here is actually water, because water is almost a half. So please, let's be very careful of misrepresenting data. All right. So right now we are moving on. We're still working on misrepresentation of data. So the example here says that this particular graph, this pictograph shows the number of grade 8 students with pets in a particular school, of course. John concluded from this graph that the most popular pet is a bird. Well, let's see. So we've got dogs, cats, birds, and fish. So John concluded that the most popular pet is a bird. Well, is it correct? Yes or no? Explain yourself. If your answer to the first one is no, what changes should we make to the pictograph to make it correct? And see which type of pet do you think this graph creator has. So which type of pet? Well, let's see. Now, each drawing represents 2 students. So, is John correct? Well, let's see. The number of students with birds here are 2, 4, and this is half. So just 1, so 5. So 5 students have birds. So I'm going to write 5 in circle here. Have birds. But to me, I can see this one is longer, so I think there are more students with dogs. Let's see. 2, 4, 6, 8, 10. Well, so I guess John was wrong. Why? Because only 5 students have birds, while up to 10 students have dogs. So John is absolutely incorrect. And the reason is because the number of students with dogs here is 10. And so 10 is bigger than 5. So A is done. And B, if your answer is no, which of course we're saying that no, John is not correct, what changes should we make here? Well, the change we need to make is John misrepresented, the graph creator here misrepresented birds here, because the graph creator has made the drawings for birds bigger than all other drawings. So when we notice, we see that all the other drawings are smaller, but the birds are bigger. So we need to erase all the drawings for the birds and then make them the same size as the other ones here. So it's going to look like this, not bigger, like this, and then we've got just the half, something like this. Exactly. So now with this looks like this looks as big as the other ones. So this is the change that we need to make here. And lastly, which type of pet do you think this graph creator has? So of course, this graph creator is probably one of the students in the graded class as well. So most likely they have a bird, because since they have a bird, they are favoring birds. So they're trying to make the drawing for birds bigger, basically. All right. So we're moving on to probability. So for probability, so basically we're seeing now what are the chances that a particular event will occur. So when events A and B are independent events, so when they're independent, we're saying that the chances of A happening does not affect the chances of B happening. So the 2 events are independent. So when they're independent, the probability of both A and B happening is the product of the probability of event A and the probability of event B. Now, so basically we're saying that the probability that event A and event B happen is the probability that event A happens times the probability of event B happening. So what I want to mention here is anytime we're using A and D and to join 2 events, we always use multiply. Whenever we're using or to join 2 events, we always use plus. We're not going to talk too much about that second one, but as you move on to higher grades, you may see more of those. But usually when you have or here instead of and, this is going to be plus instead of multiply. It's important to note that this scenario, this situation can be extended to more than two events. You can have 5 events, you can have 10 events, you can have 3 events. So for example, the probability of A and B and C happening will be P of A times P of B times P of C. Now keep in mind that this scenario applies for independent events. So when the events are independent, that means that the occurrence of one does not affect the occurrence of the other one. Example, a spinner has 2 congruent sectors colored green and blue. The probability of each event happening is green and blue. So sorry, I don't have the right color here, but this segment here is blue and this segment here is green, and this is the spinner here. So basically it's just spinning and rolling, and this is the coin. And of course coin just only has head or tail. So find the probability of each event. So blue and tail happening, find the probability of having blue or green and heads happening. So let's be very careful of or and. So let's see what to do here. Alright, now these two are independent events because our chance of getting blue is not being affected by our chance of tossing the coin and getting tail. So they are totally different things. Now, whenever you spin this, you have only 2 options. It can either land on green or blue. So, whenever you're writing probability, you're writing the probability of that thing happening on top and the overall total probability on the bottom. So you're getting a fraction. So let me just start by saying this will be probability of blue, because we have and is going to be multiply probability of tail. So you always want to figure out the portion that is going to be on top over the total. The portion they're talking about on top over the total. So, blue or green, a total of 2 things can happen, and blue is just one of 2. So the chances of getting blue is 1. The total possibilities you have are blue and green, so 2, and then times. For a coin, anytime you toss a coin, you can either get head or tail, so only 2 possibilities on the bottom, and then your chances of getting tail is just 1. So now 1 times 1 is 1, 2 times 2 is 4. Now the second one here, like this, blue or green and tail. So for this one, for blue or green, it's going to be P blue plus P green times P tail. Because remember, blue or green, so or you have to use plus. Now I'm going to show this one in 2 different ways. So here we already say that for tail is 1 over 2, because 1, you can either have head or tail. So just tail is 1 out of 2. So I'm going to say 1 over 2 times. And then probability of blue